So, today I'm gonna talk about data mesh as concept and its practical applicability and an experience that we had basically in our projects. And as sort of a disclaimer, this is 100%, let's say, experience that I went through, the observation that we made, lessons we learned, and so on. So, if you have, let's say, different experience, if you have any suggestions, any comments, ideas, this is feedback and questions highly appreciated. And just to quickly start who we are and what we do. So we at Flix, formerly known as Flixbus, so you might see some green buses if you travel across the Europe. We also nowadays operate in Ukraine. Basically, we operate in really multiple countries. So we do have pretty large scale of different sort of services which are behind basically this whole ecosystem of buses and trains to keep the system running, operational, and so on. And we're also one of the largest basically passenger transportation and mobility providers in Western Europe, and we also quite actively extend our networks. And just a couple of numbers to give you a sort of feeling at the scale that we have is that we are now at a pretty large amount of countries and also destinations, of course. In Europe, I can reliably say that we are leaders on the passenger, let's say, long distance buses transportation as such. We really covers a big audience of passengers. And nowadays we basically have multiple, let's say, high level divisions. So we're not only operating buses, but also trains. Yeah, we have a lot of locations and a lot of people involved in this large process. And we also have a very advanced and developed and large, let's say, chain of partners, bus partners, drivers, and so on. So these all things has a very big impact on, okay, which data flows we have, which challenges we face in our day-to-day work, in our mid long-term strategies, and so on. And a couple of words about me. So yeah, many thanks for such a great and warm welcome. So yeah, I do work at Flix, formerly known as Flixbus. Yeah, I am very passionate about software engineering nowadays. Super excited about cloud native engineering, different sorts of, let's say, there's some more specific things like data engineering, infrastructure of the code, and so on. Big fan of music, as you might see, also. And yeah, also love skiing. So this is a couple of words and something a little bit more specific on the like what sort of things I was related while working at Flix. So things like customer feedback and customer insights and profiling, attribution, the different sort of prediction, like for example, lifetime value, etc. Then compliance, because for us as an international company, we take very seriously the security of data. It's like one of the critical must-haves. It's not even a question. So that's quite some challenge when you have like many countries that you need to carefully take care of their regulations, national and international both. GDPR would be one of the examples, let's say, quite known nowadays in European Union, but of course, one of the, let's say, quite known regulations. Yeah, and also related to that, of course, different type of consent that our passengers, our users, give or not to give, and their possibility to manage their what they allow us to process and how exactly, which also has the quite a challenge things there because of, again, of the international situation. And also a big part of it is the recognition of different sort of sensitive information, which is also nowadays a must-have component. And depending on which system or subsystem we're talking about, that also gives some challenging and quite tricky, basically, tasks. So this is a couple of words. Now, what we're gonna talk today, a little bit more detail. So first, just to quickly recap, okay, data mesh. Very, 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 let's say, popular buzzword nowadays, but just to quickly recap what's under the hood of the concept itself, right, briefly. Then look into one of the big areas where data mesh was very big success story, let's say, for us and for evolution of our data processing and data storage and data basically organizing. Look like more or less step by step. Well, of course, not super detailed, but still sort of reasonable chapters, or how I called it here, phases that we went through in this past, because there was like several years of a journey. So that was quite a thing, starting from classy, let's say, monolithic status quo situation, then going through different sorts of decoupling and so on. Then something which we found pretty interesting and useful, and it fits really well when you talk about the customer feedback collection and structuring of this collected data. Yeah, then the way of how we organized things to basically encapsulate details of the particular legacy, or let's say new world greenfield tooling for the service ecosystem. And last but not least, something which is in progress basically is that application of data marts concept in a domain oriented way as such. So 5 big stages, phases of this evolution process. What we plan to do in the future, summary of what we've learned was a very high level bullet point, let's say. Yeah, and I would be all ears and really appreciate the questions. And we have some prizes today as well. So yeah, looking forward to that. And now let's jump into quick recap. So for those who, of course, worked with this concept, and multiple systems nowadays really follow this kind of conceptual approach. So data mesh is not something brand new, or concept is there for quite a while. However, just to quickly to recap, and for somebody who have not basically worked with that before, might be like interesting to have a quick high level overview. So data mesh in a nutshell, effectively is based on 4 main principles. So first of them is that we actually divide our data according to the domain of that information. And this is, of course, related to ownership of the data. So domain-oriented data ownership. So for example, if that's information about customer retention, that's most likely marketing, right? If there's information about taxes, that's probably finance. If it's about booking funnel, that's most likely e-commerce domain, and so on. The second one is that we treat our data sets, as a product themselves, which that way of shaping things allow you to reuse and apply many software engineering practices that we usually normally apply to our software components, like quality analysis and assurance, like basically measurement and some sort of SLOs and SLAs, and so on. So various practices, observability, for instance, and so on. So the way that your data set is used as a mature standalone product itself for various purposes. The next one is more about scalability and feasibility, if you want. So the data platform should simplify like routine, the toil and the work, which is repetitive. So you don't have to, do all the integrations yourself. You don't have to build pipelines and so on. So as much self-service and as much automation that basically allow you to concentrate on the actual let's say, domain-related, business-related work on the data product, and allow you and enable you to do as many things as possible as a sole service. So without need, let's say, to raise some service desk tickets for your platform team, or some, feature requests for your centralized data engineering, big data engineering team, and so on. And a fourth principle there says that, okay, of course, part of the ownership of the data automatically requires its governance. And when we talk about domain-oriented, decentralized ownership, what comes next as a consequence of that is the federation. So if you have multiple domains, of course, you will have multiple teams in it. And the way how the data is governed, how you share the access, how you monitor and audit your compliance, and so on, this is also critical part in those kind of setups, because then it allows you to empower teams with autonomy for this, let's say, operational and sharing work. Again, reducing operational efforts, reducing dependency on the platform teams, and also reducing time to market, eventually, of course. Yep, and just a quick illustration of that. So yeah, today we already mentioned, for example, NX, one of the partners is TuneIn, right? So the situation when you have artists, you have audience who listens to them, users, and you have there some sort of, songs, podcasts, audio records, and so on. So this is, I would say, a pretty classy model. And here, this picture effectively describes that situation where you have multiple domains, so multiple ownership as such, and in which of them you have certain types of data sets that you would like to actually process and share with other domains as well. So a sort of, kind of complementary and somewhere, might be even overlapping. However, there are clear boundaries of that domains. And all of the, let's say, low-level operations, the platform work, ideally automated and encapsulated into self-service. Then your data sets, which you expose and you want to share with other domains, basically not necessary are the same as your internal representation of it. So you do some sort of views, some sort of facades, aggregation, whatever makes sense from usability of that target data product. So that is done basically also within that domain. The process of sharing things themselves, which basically is related to governance and the federated setup, is of course, so the part of the domain, let's say, duties is to manage sharing, manage requests and approvals of data access as such, and so on. Yeah, going to the next part. So that was like quick recap on data mesh. And yeah, so once we share the slide, there are two links I definitely recommend you to look through. So one is the presentation from the, basically one of the, let's say, authors of the terminology and the term basically data mesh itself, and very nice descriptive article from Martin Fowler's resource as well. And now getting into more details, okay, what exactly we solved with concept of data mesh. So we addressed the customer feedback workflows, and to start, I'd like to just outline the high level data flow for the customer feedback information and the Flix. So we might get some information from our customer support, then of course from the phones, from SMS as well, emails, also valid channel. And also we send the invitations to surveys via mostly those two channels, so SMS or emails, depending on the market, and so on. And that data is like first tier basically of the collecting that. So it goes either to Salesforce or to Survey tool, which is SurveyMonkey in our case, then streamed into Kafka, and after that collected basically in a Snowflake, and finally is made available for the business intelligence, reporting, advanced analytics, and so on. This is a super high level flow from the customer down to analytical teams. And one of the examples, like what it is when I say, okay, customer feedback, customer surveys, what it is. One of the good examples of such survey is the NPS, or Net Promoter Score, basically survey, which is in a nutshell, you might see that a lot when you use some services saying, hey, could you please rate your experience? Is it good? Was it bad? Just put a number from 0 to 10, from 1 to 10. Sometimes it's just 3 options, like happy face, neutral, and some kind of angry face. And basically, this is one of the surveys that we take as such. And the data that is collected while this survey flows exactly through that scenario and the flow from the previous slide. And now getting into those 5 phases. So the process of evolution that we started 3.5 years ago, went through, now phase number 5 is in progress. So it's still ongoing things and just some pain points, lessons that we learned, and I'd like to share today. Phase number 1, and probably people who worked with a legacy monolithic system, when they say, okay, now we'll migrate into the cloud and just put things into containers, that most likely, your feeling internally is like, okay, let's just do it like on that slide. So burn old world and just put it somehow somewhere. It's just sort of possible approach. However, there are other options in that. And basically, to depict what we had before we started, so we did have some sort of monolithic multi-module application. We have legacy survey tool, and we had a sort of monolithic database with multiple schemas, however, luckily. And of course, on top of that, the reporting tool. But the problem there was that everything was interconnected to everything. And that's not fun, especially when you try to do some updates and changes and so on. So you have a huge tail of dependencies, side effects, and so on. And of course, it makes things really, really slow. One way, of course, what Alex described, potential option would be switch to DynamoDB. However, we also considered other options, and we started with the baby steps. And the first, as you might guess, right? So the old good principle, divide and conquer. So what we did, we split that monolithic data layer, where we say, okay, yes, the data is related, of course. So your passenger information, your operational information about tickets, about rides, and so on, of course, it is related and connected to the customer feedback, right? Because customer give you a feedback about a ride experience, right? About the trip that happened before. So of course, that trip was stored in the main system, let's say main database. However, not necessarily they should be interconnected to each other and dependent. And that already decreased drastically operational efforts and also opened certain basically possibilities for next steps. So things like, okay, now when we decouple, we can talk about migrating components incrementally to the cloud. And also, why I split it into those 5 steps, 5 phases, is that any 2 consequential phases, they are easy to roll back. They are incremental. So it was always a safety net, safe, clear rollback process if something goes not as expected. So this is exactly like that. We split it, but we still had quite an easy option to get back basically to where we used to be before. Next part, right, is that, okay, I actually want to separate, right, my responsibilities, because when I had everything in a one schema. It was sort of like the same people or similar people had to work on many things simultaneously, and we would like to structure it, actually reduce the cognitive load of the person. So for instance, what I'm talking about here, if we take this already like a decoupled system, we still have the situation we have multiple roles. So there might be like a designer or content manager, there might be software or data engineer, right? Like a front end or back end. And there are also reporting people, analysts, management, and so on. And with the old monolithic, like all depend on all setup, the problem was that, okay, they're sort of super overlapping and stepping onto each other's toes. That's the problem, because then sometimes you have same effort than 2 times or even more. And this was not good from any perspective. And this phase is effectively something which is more cultural and organizational rather than technical. So we actually changed the processes behind that. So we split and divided the areas of expertise and applicability. So if you think of it in the data mesh concept, it's exactly starting to apply this, federated and domain-driven components. Not to full extent, but at least start with the baby steps there. Yeah, and once we've done that, then we say, okay, we want to actually optimize the way how we internally represent this information. And we faced a very large challenge of the basically sparse data representation. So in total, we had like over, I think, 400 different questions in this NPS survey as such. However, the actual questions which are shown to the passenger, they are determined dynamically based on the right information and also based on answers that customer has already given. So it was really challenging thing to how to model, how to store this information. And something that we found quite useful for us was the so-called entity attribute value model that we actually took from the health industry. And there it is used and worked really, really nice for representing heterogeneous patients' data. So in the health, in the medical world, you have a lot of measurements, a lot of information about the patient history. And that data is might be like really different type. Like it might be number, it might be some sort of text. If that's a number, okay, which measurement unit it is, and so on. So that brings the big challenge in modeling this data using classy relational, entity relational basically model. So classy relational databases table and so on. But this thing also fits quite nicely. We say, hey, we have different questions which are sort of like profile attributes which are dynamic and it's very heterogeneous. So it might make sense to try it out. And as we figured it out later, it worked really well for us. And just to give you an example how that looks like in terms of modeling. So let's say we start with a usual the table in relational database, right? Nothing special. 3 columns, the identifier. We do have sensitive information here right away, first, last name, of course. Questionable whether age could be, classified right away as sensitive information or like, indirectly sensitive information, also quite good one. But let's assume first name, last name, definitely. And now when we decompose it to this EAV model, basically, what do we have? So we say one table stores the type of the data, exactly like what's the unit attribute type. In our case, we had first name, last name, and age. Another table just stored values. It doesn't really matter what is the nature of that value. We just say, okay, there are just different values for something, and then basically there is a link between. So say, okay, how do I understand to which entity, which my domain entity is related, and which attributes does it have, and what are types of this attribute? And that's how they are linked. So it's the same data represented in this model. As you see, much more data and so on. And if you have classy situation when you have fixed structure, you have clear possibility to set it up as a regular table, normalized third normal form. go for it. Unfortunately, sometimes when you have sparse representation, so you actually have something like this, when you have more empty cells in your table than you have basically filled cells, then this model helps you a lot. And for example, for such situation where there is incomplete data, and you can imagine like if you have 400, actually more than 400 questions, classy table would be basically more than 400 columns. And realistically, average number of questions which were effectively shown to the customer around 50, right? So yeah, by the nature of the data, you always have vast majority of your columns, of your cells being empty. So you have a lot of improvements there. And right away, for example, as you see, so the size of this entity, let's say table, it's shrinking drastically, let's say. So it's a very efficient way of representing that. And the good thing about such representation is that, okay, you are very flexible in the way how you want to model that to basically meet specific demand for a specific use case. So let's say some other domain. Like, okay, if I need to represent this for financial guys, so probably I need a view which says, okay, what was my, I don't know, the prices for that. Or if I represented, for example, if I take this example, okay, so what was the average age of the participants, right, of the band? Or if I want to provide a sensitive data report for my compliance or legal department, okay, I'm interested in sensitive data. So there will be like, okay, the personal information like names, probably mailing addresses, phone numbers, credit cards, and so on. Yeah, next phase is about unification and encapsulating the actual specificity of tool ecosystem themselves. So we did have a legacy tool called mSurvey for collecting the feedback. Okay, we fed it up into Kafka, again, real-time data. Then it landed in a MySQL and then gets basically to the business intelligence tooling. And for the new world, since it was greenfield, we decided to go, let's say, more mature, however, a little bit more complex approach right away. So still real time, of course, still go to our streaming core part of the system, which is based on Kafka. Then we offloaded right away to Snowflake. It's like one of the things that, for example, Alex mentioned today as well, pretty classy approach when you want to get data out of your streaming ecosystem and put it into your warehouse. It might be Redshift, might be Snowflake, you might go even with more like data lake approach with S3, Athena, Glue, and so on. In our case, it was Snowflake. And then we exposed the data set from the Snowflake to the Power BI in our case, which also has a quite nice integration. And then I said, okay, this is something that, of course, work. However, next maturity phase there would be if I abstract the fact that the data was taken from different tools. And that's where, as a prerequisite, was the previous step needed, because the way, if I present it as AAV model, then I get rid of this need to structure my data in a fixed, in a sort of hard-coded way. I am flexible in terms of which representation I can put, basically, independently of my underlying raw model of the tool. So first layer of transformation actually happens between the tool and the raw storage. So we say, okay, we just convert it to this EAV model. And then it doesn't really matter. So I can model whatever data set on a higher abstraction level, which is suitable and useful for reporting and business analysts as such. So that was like a next step. And this step, encapsulating it, allowed us super smoothly, zero downtime, and honestly, even almost without the users, when I say users, so the people who are actually analysts in the company, to decommission the legacy tool. Because for them, once that information was encapsulated, right, it didn't really make a huge difference unless they want to backtrack source the origin of that information. If they're only interested in attributes and actually answered questions, it was absolutely transparent for them. Like, didn't really have any sort of impact. However, we still provide a possibility if you want to understand, okay, where that thing comes from, you can still get that information as well. And phase number 5, which is in progress right now. So as long as we use Snowflake heavily, we're very happy about it. So nowadays there is a quite interesting and promising feature called data exchange. You can think of it as a sort of a private marketplace, basically. Yeah, and I also, if you're interested in that sort of stuff, I highly recommend you to check out the docs. It has some quite nice description, and this diagram was basically shamelessly stolen from that documentation. Hope Snowflake guys don't mind, but it's really cool thing in terms of actual implementation. Well, mostly about self-service and federated things. So it drastically decreases your work in terms of, okay, how I set up my permission model, how I set up tools which will allow my product teams to actually share things. How do I set up and track the access and the granularity of those things? How do I ensure that there is a proper process of requesting data sets and approval if needed, especially when it comes to some complex process where you actually request, when one team requests access to data set of other team and the data set has sensitive information or personally identifiable information, which automatically means that that sharing, that permission grant requires also legal approval, not only approval of the technical owner team. And yeah, this is something interesting. Of course, there are some limitations, and we're not talking today about the data exchange, but this is something which actually drastically simplify our work as data platform team for maintaining this distributed, decentralized ecosystem for basically data products and such. And of course, I mean, one thing is theory, and another thing is practice, right? So theoretically, documentation looks nice, diagrams look nice, it should work. However, in practice, it didn't work right away, of course, right? And basically, again, we really got some nice benefits and pros from the fact that we build this raw AAV model, which allow us to do something like that. We say, okay, I have my raw data, and now I can actually build as many representations as I need per different domain. So, okay, if that's business intelligence, there is one bunch of data sets. Let's say views, start simple. So like super thin, approach. Okay, when we talk about some customer profiling, customer attributes, and insights, that's something specific to most likely marketing, retention, and so on. So we build a separate bunch of views and data sets, like data mart-ish, let's say, approach. If there is some operational information which requires the analysis and so on, for example, for traffic control and so on, okay, there is a separate dedicated one. And really, what we've learned that you'd better not to reuse same, let's say, tables, same views. So it always pays you off in the mid and long run if you create dedicated representation per domain or per subdomain. That's like really something we learned in a hard way, basically. So if you consider to do or not to do that, my personal advice, don't share views or data marts, yeah, if I use terminology, across multiple consumer domains. And this is basically something which is ongoing process. So this, we're in the middle of phase 5. And to complement that, to kind of finalize that, right? So what we plan to do in the future. So first, actually try out this thing. So something that we developed ourselves on top of the native roles and users model. So try to reduce the amount of operational work and the kind of custom solution that we developed over these 3 years into built-in functionality of Snowflake Cloud as basically primary warehousing ecosystem. Then another interesting part is also about information on data sets. If I treat them as mature products, right? So for example, what I do for software products, I have documentation, I have like diagrams about architecture, topology, connectivity, quality of the data, expectations, down times, SLOs, SLAs, and so on. And because that growth over the time, so also unifying that information, some sort of structure. This is also quite a challenging thing when you have, like we have nowadays, more than 70 teams, engineering product teams. So it's quite a challenge itself, just to unify that and make it available, useful, and easily accessible, especially for cross teams and cross departments, cross domain approach. And last but not least, okay, concept of the data sharing and data products is a really nice thing, and it's not necessarily bounded to, let's say, your databases or warehouses. So it could be applied also to streaming system. It's also kind of in progress right now. It also could be applied to your distributed, let's say, data lake, if you build one, as we do, at least try. And this is something which could be extended probably also to other things. However, those are our, let's say, nowadays two kind of promising options that we want to explore as such. And getting to lessons. Again, could talk for that for a very, very long time, but just like top super high level bullet points here. So first, the main thing when you do, well, it's not specific even to the data mesh appliance. It might be taken for any sort of innovation. However, for us, it really worked. We showed basically result. So we did something, it was incremental, it had very, very quick the business value, which allowed us to basically establish sort of the traction. So things that we do had basically impact, positive impact on business, and then it allowed us, to continue more efficiently and gain credibility, reputation, and all those, let's say, non-technical organizational things. And also, it's always nice to get actual feedback. So surprisingly, just talking to people, talking to your users, stakeholders, your analysts, other teams, data scientists, and so on, might give you really interesting results and really nice and low-hanging fruits to implement, feature requests, and so on. So again, if you have a choice to assume that, okay, we know how it should be, and you have a other option, ask your stakeholders, ask. Another thing that saved us a lot of sleepless nights, I would say, and pages, in our on-call support was that we really kept the changes incremental with a clear rollback process. So it was really, really helpful. That, okay, something goes wrong, we try it out, didn't work out, roll back to previous state because that's for sure is stable. Okay, we'll do like kind of a homework, analyze mistake, do postmortem, adjust, adopt, second iteration. So it really helps your process stability. Then something that I already said, when you decouple how you store the data from its representation for specific need, it really simplifies and reduces amount of actual work that you have to do, especially when you have cross-team sharing. So amount of cross teams, cross roles, cross users, cross account sharing, it just shrinked like, I don't know, 10, 100 times basically, which of course reduces operational complexity of that. So service itself in its term. So for some super lucky cases, we fundamentally eliminate even like types of service desk requests. When people were able and they got a feeling that they are actually, they have ownership of things they work on and they can achieve something on their own without explicit request to us to do something, that basically eliminates 3, 4 types of service desk requests. So people were able to do it themselves, which also reduces like a pressure and a load on us as a platform. And also something to remember, the data mesh, even so it looks nice and it really worked for our use case, it's not, like in the joke, like I have not heard the question, right answer is Kubernetes or right answer is data mesh. No, it's not, of course. So analyze your situation, analyze your actual use case, your business requirements and restrictions and your context, and make conscious decision, preferably data-driven. And don't just take, okay, it used to work for Flix and for customer data. We also have some customer data. Let's just take it over. use it wisely. Yeah, and hopefully if you got something useful, at least some points, right? So you save some operational expenses. You decreased your time to market, probably faster delivering your features, more like better insights, better A/B testing. So you save some money basically on your platform, and of course you can donate it, right, to support Ukraine and Ukrainians. Highly welcome. I think we do have, right, the QR code somewhere here, I believe. And yep, thank you very, very much for your attention. If you would like to chat more detail or connect personally, there is the QR code for my LinkedIn. So feel free to connect and share your experience. I would really, really appreciate and super interested in your cases. Probably something that I've told today doesn't work for you for also some good reasons, and you would like also to share those pain points. So it would be really cool to communicate on that as well. Thank you very much, and ready for questions.
I want to say that the pictures on your slide are just so awesome. This is absolutely great. And also I think that the one that has the lessons learned, you should just print it. I mean, everyone should just print it and put it on the wall because everything just makes so much sense. Like if people were following it, we probably would have so many less problems that we have in the real life.
Yeah, I really hope that, because I mean, there were, some blood tears that we had to, tear away, and sleepless nights, rollbacks, and so on, that we came up with this. It looks nice and like logical, but it was not right away. It's not like, platform team woke up in the morning and said, "Whoa, let's do it that way." No.
I'm glad that you now have it all working and that the tears are in the past, and hopefully you will not be in the same situation in the future with all of your lessons learned. Let's get to the questions. I reviewed them, and that's going to be fun. Okay, so the first one, the most popular. Let's say you have the client at Flixbus, who writes from country A to country B. Both have different GDPR. How you will store them to satisfy both countries' rules?
Okay. It's not directly related to data mesh concept. However, there is such kind of concept when we talk about tech GDPR called purpose. Basically, purpose of data processing define what exactly you're gonna do with your sensitive information. Depending on how you structure your purposes across multiple countries, where you basically can treat them as a separate type of processing activity. Something is called ROPA, I think, record of processing activity. If you do it that way, that unifies your audit possibilities, basically. So GDPR is the specific name, is basically European Union specific. For example, there is a CCPA in California, LGPD in Brazil, OIS in Turkey, and so on. So yeah, GDPR, be careful when you use term GDPR itself.
It's so confusing. There's so many regulations between different countries.
Yeah, unfortunately nowadays it's like like security and logging back in the days, and metrics. It's like basically cross facet the concerns, and now compliance is one of them.
Yep. Okay, going to the next one. How you separate domains? Where are the boundaries?
Business areas. So sort of, if you try to link it with something from software engineering world, I would say more or less similar to domain-driven design. However, domain-driven design is still about software. Here we talk about higher level things. So if you're familiar with what, let's say, Conways law or inverse convey maneuver is, it's like organizational thing, which says, okay, if you structure your company in a way, okay, department A, department B, department C, eventually, after some period of time, engineering teams will develop a software that will reflect the structure. So if you structure your company departments in a way like, okay, there is a domain expertise concentrated there, marketing, e-commerce, finance, compliance, like foundation platform, eventually, so it's eventually consistent thing, right? That will get to the structure you actually want. And if you try to organize it around specific domain knowledge expertise, then it gives you to give you the benefits.
You probably had a feeling about our next question, so let me ask it too. Does your data mesh follow Conway's law, or it's separated by domains?
Now, Conway's law just says that it will be eventually separated. It doesn't say what exactly will happen. Just like eventually, if you had one team that work on monolithic application, now you split it to, let's say, 5 teams, that eventually your software components will form a distributed system, most likely of service-oriented architecture or microservice-oriented architecture, with ownership per service or per bunch of services by specific team. So it's like underlying mechanism of changing the organizational part, not technical part of the structure. Yeah.
Got you. Next one, how do you resolve when data is similar and is shared by different domains? Whose data is more trustful?
It's a very, very good question. And not prerequisite, but important thing to keep in mind here, that one of the core principles here, and this is very, very, very big for me, it was like a game changer, is that there is no centralized authority which determines that this data is good or bad. So it's up to owner team to provide criteria, to provide information, and to maintain like kind of announced data quality of the data sets itself. It's like, let's say you have product engineering team, so you do quality assurance practices, quality gateways, things like code reviews, continuous deployment, and continuous integration. It's a part of your day-to-day job. And it's not even the question. I mean, there is no, like, I would say if we talk about product team setup, it's all done by the same team, right? There is no separate someone magical that does, let's say, QA for you. Absolutely, detached from your context. So very similar thing here. Team, which exposes the data set as product, is responsible for description of this product, clear process of requesting access to that product, clear description, what are exact, let's say, quality boundaries, what, let's say, frequency of data updates, what was data freshness, and so on, what's the data precision, and so on. The main challenge for platform team, like for us, is to provide convenient tools for the product team to do all those things, not do that instead or for that team. That's the main challenge, because most likely we have more, let's say, deep expertise within the data engineering, platform engineering, and so on, but that's not the goal. We don't want to make all of those, 70 teams like in Metrics, all of them, make them Agent Smith, all of them. No, all of them data engineers. We want to give them convenient tool which will help them to deliver their products and their data sets. It sounds abstract, but it has immediate implication. So team A, who uses the centralized approach, building data pipeline, which takes them 2 weeks, so sprint. And there is a team B who uses a decentralized approach and uses this data set sharing and can build, let's say, the same analytics within 2 days. Now multiply by salary of engineers plus your operational expenses, and you have pretty clear number.
Yeah, make people responsible for the data they are providing to you, right?
Yeah.
Okay, we have another one. Does Snowflake have any competitive alternative? Can AWS be used to build cheaper alternative?
Oh, I could not say if it would be cheaper. That heavily depends on how you use it, of course. I mean, there's a whole bunch of tools, cloud native, so we're talking about things like Redshift, BigQuery, and so on. Snowflake worked for us, and for us, Snowflake was iteration number 3. We tried out multiple approaches. It was not like we woke up in the morning, hey, it will be Snowflake. No. It was just like data-driven, also several lessons learned the hard way. It might be the case that Snowflake is not applicable for you. It's not a good choice. What is a good thing is to compare multiple options and make conscious decisions of that. Yeah, it sounds again like a philosophy, but yeah, for us, it was already after 2 very painful attempts, and Snowflake was attempt number 3, and it was really nice match for our cases.
Okay.
Cheaper depends. I mean, really depends. It's not like there is a also silver bullet. I mean, you can make even your DynamoDB bill like crazy if you do things in the wrong way. And the opposite, if you know how to optimize things in your warehouse and you don't use it as, let's say, as LTP database, again, your bills won't go through roof or might be even lower than, your more relational solution.
Okay, I think I'm going to ask you last question because we have some limited time and it's quite late now. How you are used AWS services in this Flixbus architecture?
Okay, very good question. So as long as, okay, so the high level flow there, so when we started was getting data, basically, the data going through Salesforce and the SurveyMonkey as tools. So the way to interact with them was like entry point into AWS, because Salesforce itself is a software as a service, right? It's like an encapsulated system that you can access in a various way. SurveyMonkey as well. And there we have 2 interaction interfaces. So in one case, it was HTTP. So SurveyMonkey allow you to export the data. If you need, you can do it in a real-time streaming way. We could afford doing it as small batches, like hourly, basically. And from Salesforce, we actually built a CDC streaming. There are also like how exactly that's a separate talk, how to build CDC from Salesforce into Kafka. And Kafka is not the only option. Yeah. Besides that, Kafka itself is one of the options. If you want to be like more AWS native, direct competitor of the Kafka, which is native AWS tool, is Kinesis. Of course, if you are advanced user of AWS, you know that nowadays there is a managed streaming service for Apache Kafka, MSK. So you can have managed Kafka for you by AWS. You can even go fancy and use serverless Kafka mode, which basically gives you auto-scaling of Kafka. However, in our case, we have a more classy setup with AC2 instances, EBS volumes, secure networking, and so on. Again, separate conversation of how to set up Kafka on AWS, which options you have. Then data flow between streaming system and Snowflake, something like directly related to previous talk. Really nice way is to offload data have like intermediate sort of stage, offload data to S3. And then there is a really nice concept called external stage, which allow you to import massive amounts of data in a very efficient way from S3 to Snowflake. So check it out, called external stages, basically, of Snowflake. And Snowflake to Power BI in our case, that's again something which is like built-in Power BI integration. And other tools that we use sometimes, for example, for other advanced analytics was Amazon QuickSight. And for things like machine learning and experiments, SageMaker, AWS service, and ecosystem. So there was some things there as well. And of course, most of the components, VPC, please use secure networking.
Very good advice, by the way. All right, I think we're done with our questions. Now, Taras, a very complicated question to you. Two best questions that you like the most.
Yeah, well, definitely about cross-country regulations, because it's a huge pain in which place. Yeah, and the second one is, let me think. I think really nice one about was a Conways law, because it's not obvious at all. It's something that you cannot have it in 5 minutes or 5 days. It's like going into gym, If you like go for on training for 8 hours, you will be like, dead, but it won't give you nice abs or something like that. You need to do this regularly, and then you start to observe things over the time. And that's exactly how it works there, unfortunately. So you cannot get this in the blink of an eye. So those two, I would say, yeah. I think it was question number 1 and number 3. I might be slightly wrong, but yeah, cross-country regulation and Conways law.
Okay, I see you're a very organized person. You had a notes to mark the best questions.
Thank you.
Okay, so we have a winners. Organizers will contact you and discuss the details, how to get your prizes and so on. Meanwhile, Taras, thank you very much for your presentation. That was very interesting to watch. I absolutely enjoyed the lessons learned. This is a great summary, and I'm honestly thinking about printing it and put on the wall, so just to keep all of these things in mind. That was very nice of you. Thank you.
Thank you so much for having me.
Okay, basically this is all that we had for today. Just stick with me for a couple of more minutes to have like the ending of this meetup. First of all, I would like to say absolutely great thank you to the speakers. I'm so glad that they were able to make it, that we had an ability to listen to them. Thank you to everyone who has joined. I believe you had a lot of fun and interesting things the same way as I did. We kindly ask you to fill the feedback form. It will be sent in the chat, and also if you'll miss it in the chat, you'll have it's sent via email probably on Monday. Please fill this form. We want to make things better, so if there's anything you liked or didn't like, make sure to tell us so we can improve. Also, another important thing of our meetup is our charity foundation for Ukraine, this 50 occlusive bandages. I'm very happy to say that we hit our goal. Thanks to everyone who actually participated. It all matters. We feel the help. We appreciate it a lot. So thank you. And that's pretty much it. Stay tuned. Make sure you follow us on our social networks. Enjoy your evenings and talk to you soon. Thank you.